not the inviting kind. Okay. So anyway, so most people would look at those messages and just get rid of those messages, because they know, okay, we better not invite strangers who do not know me at all. I don't know that person. But sometimes people are just so bored and they got nothing else to do, so they would actually take the invitation and say, well, what harm can be done? It's all online. I'm not going to meet that person in person anyway. So no harm can be done. I'm just going to chat with that person and share some stories and whatnot. And sure enough, those people are just staying online completely without any physical meeting and whatnot. So it should be fairly safe. Except in this case, the other side is not a predator. We are not talking about criminals. We are not talking about sick crime, criminals. We are talking about FBI agents. Okay, so we are talking about FBI agents pretending to be a Facebook user to try to convince other people to add them onto their friend list. Now, what happened is the FBI figure out that sometimes when people don't want to talk about stuff when they are dragged into the FBI headquarters, they will talk when they're online. They will talk about stuff that they would normally not talk about on Facebook. So they were using this method to collect information on suspects. Yep.
There was this one story about I think like Sweden or some European country where these schoolgirls had like this ring where they were using to cheat, and then one of the girls went and talked about it on her Facebook, and they ended up getting caught.
Yeah. And not only FBI agents, insurance companies do that too. Insurance companies now use Facebook to collect information on people that they want to collect stuff from, or the people they want to investigate. They now use Facebook as a means to keep track of what those people do and try to catch them doing or saying something they're not supposed to say, and use it in the court in the process. I can see people going home and just say, I'm going to delete my Facebook account now. I have a Facebook account, but I don't use it much. So. I get people saying, oh, today is your birthday, blah, 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 blah. No, it's not. Because Facebook can release your birth date. It can send people that you know and say, oh, this is so-and-so's birthday today. You might want to say, happy birthday to those people. Of course, I don't give them the real birth date. I mean, that's... All right.
January 1st?
January, no, that would be too obvious, right? February 28th, 29th.
29th.
Yes. That would be a good day to put.
Every 40 years.
Sorry?
They're going to send you they're going to tell your friends that every 4 years you have a birthday. Not every year.
Yep. And sometimes not even every 4 years.
Where's that?
Not every year divisible by 4 is a leap year. Like 2000 is not. 2000 is a leap year. 2100 is not going to be a leap year.
Yeah, it's divisible. Years that are divisible by 100 and not divisible by 400.
Right.
Are leap years.
It has to do with. It's kind of slow. What? Say it again.
Years that are divisible by 100 but not divisible by 400 are a leap year, or aren't leap years.
Uh-oh. I think I'm having the same problem now.
She went to sleep.
Come on.
How come you deleted the found and changed around the...
Because I don't need that. I don't have that variable anymore. With this approach, I don't need that variable anymore. I still need the f variable. I guess I should have kept found, but it's not going to be used in the same way as what we did last time. Oh, great! I have the same problem.
Do you need another mouse?
Hmm?
Do you need another mouse?
Another
Mouse.
mess?
Mouse.
Mouse.
Mouse. Squeak.
No, I don't think it's a mouse issue. Oh, it is. It is.
IT guys know.
That's interesting. So the mouse was. I guess.
Probably dead.
No, the battery is good. I must have accidentally clicked one of the other buttons, because this one has got a gazillion buttons on it. Well, 2 would be good. I don't want to use a one mouse button like some Mac people do. Yeah, I got only one finger, and therefore I only need one button. No, I think I need a little more than that. Okay, very good. So that was a mouse button. Good diagnosis right there. All right, we need another column. We need column F to reflect the result of the search. So we'll go ahead and include that here. So F gets I is less than bar A bar. Very good. And sequentially number that. All right. So this time, what did I change compared to the first version, the version that actually had a problem? I changed the order of the condition. That's all I did. Okay, let me just point out what I mean by that. The first version of the program, which had a problem, evaluates A bracket I is different from K, and then it evaluates I is less than bar A bar. This one evaluates it in the opposite order. I first evaluate I is less than bar A bar, and then I evaluate A bracket I is different from K. That's the only difference compared to the first version. Okay, so how can that solve the problem? We'll go ahead and try it out. Line 1 initializes I to 0. Line 2 asks the question. So in this case, I first ask I is less than bar A bar, which is true because I is 0, bar A bar is 2. 0 is less than 2 is true. And then I ask A bracket I is different from K, which is also true because I is 0. A bracket 0 has a value of 4. 4 is different from 3 is true. We have true and true. The result is true. We go to line 3. Line 3 adds 1 to I. We go back to line 2. And then we ask the same question again. The answer is true again because this time I is 1. A bracket I refers to A bracket I refers to A bracket 1, which has a value of 2. 2 compared to 3, they are different. So the first condition is true. The second condition is, I reversed the problem. The first one is I is 1, 1 is less than 2 is true. The second one is 2 is different from 3, which is also true. True and true is true. So we go to line 3 again. We add 1 to I goes from 1 to 2. We go back to line 2. Now, how is this how is this not causing any problems this time? First thing is to ask, is I less than bar A bar? 2 is not less than 2. Now, because this is a conjunction, if one side of a conjunction is false, then the whole thing is false. So that means if I'm lazy, I can just say that this whole thing is false and I'm done. That's how laziness is saving the day. Okay, so sometimes lazy is good, not often. So then we jump directly to line 5. Line 5 is asking, what is the value of I is less than bar A bar?
4.
It is false. Okay, so that means found equals to false, which means we could not find the value 3 in the array. But the important part is, when we evaluate the condition of line 2 the third time, we did not evaluate the right-hand side. We only evaluated the left-hand side. If that is enough to give me the result of the calculation, I don't even bother to look at the second side. That is what we call the lazy evaluation of Boolean expressions, which is also called the short-circuited evaluation of Boolean expressions. Okay? Are we doing okay so far, of why this solved the problem? So the next question now is, it seems like this type of, short-circuited evaluation seems to be pretty important, because without short-circuited evaluation, we have to go back to the other algorithm where we have an explicit variable to keep track of the comparison result. Do you guys do remember the non-lazy version of this, which is longer and more cumbersome? This one is shorter and is more direct. The question is this a part of the language definition of real programming languages? That's the real question. Just because it makes sense in pseudocode doesn't mean that most programming languages will use this same approach. And the answer to that question is yes. As far as I know, all programming languages today use this particular method. They all use short-circuited evaluation. So that includes, for sure, I know that C, C++, Java, Perl, PHP, Python. I don't know about Ruby on Rails. I suspect that is the case as well. Visual Basic, and so on, they all use short-circuited evaluation. So a trick like this would work on all of those programming languages.
Do we spend time still trying to evaluate the other side at all? Or does
No, it won't even. It just short circuits the whole thing and not even spend time to evaluate the other side. The problem of evaluating the other side is not just the time that you take, but in this case, if I is not less than bar A bar, it means I is no longer a valid index into the array A, so I don't even want to touch the right-hand side because of that. And sometimes in this type of situation, we also call I is less than bar A bar what we call a guard condition. It's called a guard condition because it guards the second part of the condition, of the conjunction, from using the wrong value as an index. So do we have any questions about the short-circuited evaluation method? No questions? Now that is actually very important because sometimes we want the other way around. Sometimes with a conjunction or disjunction, we actually want to evaluate both sides instead of evaluating only one side. And that happens when you have a function call on the other side, on the right-hand side, and the function or the function call has some kind of side effect that you want to accomplish all the time. So we are not going to talk about that at this point because we have not talked about subroutines yet. By the time we get to subroutine, then we might go back and revisit the short-circuited evaluation and try to explain why sometimes we don't want short-circuited evaluation and we want to evaluate things the long way. Okay.
Because you probably want to tell them what's wrong, right?
No, there's nothing wrong in this case. The logic of this code is not wrong. It is still correct.
Well, right now it just tells you that 3 is not in the array.
Yeah, but that's fine. That is exactly what I wanted to do. Yep. Okay. So now we are pretty much done in terms of the notes included on Moodle. We are now done with arrays, and we are going to move on to we are done with short-circuited Boolean operators already because I just described what short-circuited evaluation is. So we are now going to move on to searching in the sorted array. So let me highlight that one just so that we know where we are in the notes. So now we are turning on this light bulb. And we're going to start with this module. And we'll start with an example. We'll start with an example with linear search and explain why having an array sorted may be helpful sometimes with just linear search. So now we have 2, 5, 10, 11, 14. Okay, let's just say that we have an array with 5 elements, and these are the values of the 5 elements. And I tell you ahead of time that the array is guaranteed to be sorted. Okay, so this is the big difference between what we are dealing with now